1,000 meters below the surface of the Gulf of Mexico lies a lake. It has its own shoreline, its own surface. Ripples even move across it. But this is a lake at the bottom of the ocean, and it is a place of death. You are looking at a brine pool, a pocket of water so salty, so dense, it refuses to mix with the seawater around it. It sits on the ocean floor like a trap, a perfectly circular pool 100 feet across with a strange, shimmering surface. Do not touch it. For any creature that swims past its shoreline, the journey ends instantly. The extreme salinity is a shock to their system, a fatal shock. They sink to the bottom where the water pickles them, perfectly preserving them for years or decades. Scientists aboard the exploration vessel Nautilus gave it a fitting name, the Jacuzzi of Despair. And here is where it gets strange. The water inside is warm, around 19 degrees Celsius. The surrounding deep ocean is a near-freezing 4 degrees. It's a warm bath you can never leave. The water is 5 times saltier than the ocean. It's so dense, a submarine could literally float on its surface. But the salt is not the only killer. The pool is saturated with toxic chemicals. Methane gas bubbles up from the floor. Hydrogen sulfide fills the water, making it completely without oxygen. It is a chemical soup from another world. Think about what that means. This isn't just a curiosity. Scientists see these pools as time capsules. They are a glimpse into the toxic oceans of Earth's ancient past. Oceans that witnessed the planet's greatest mass extinctions. During the Permian-Triassic extinction event, 96% of all marine life vanished. The oceans were poisoned, low in oxygen, high in toxicity. Sound familiar? These pools are a living laboratory for how life dies on a planetary scale. For years, scientists believed these death zones were rare, isolated oddities confined to a few deep pockets of the world. They were wrong, and what they just discovered in the Red Sea is something else entirely. You are sinking 3/4 of a mile beneath the waves. The water outside your submersible is just above freezing, and the pressure is a crushing 1,800 pounds per square inch. Down here, there is no light, only what you bring with you. Your beams cut through the blackness, revealing a barren floor of mud. And then, something else appears, a shoreline. You see a distinct edge, a coastline of mussels, their shells gaping open. They form a perfect ring around a pool of water that seems to shimmer. It looks like a lake on the bottom of the ocean. But any creature that crosses that shore pays a terrible price. You see a crab frozen in place, perfectly preserved from months ago. Pickled. This is a brine pool, and it is one of the most hostile environments on Earth. Here's what you need to understand. That water isn't water. Not really. It's a supersaturated brine, a liquid so dense with salt it can be 5 times saltier than the ocean around it. It doesn't mix. It settles into a distinct layer like oil on vinegar, a sea within a sea. But the salt is only half the story. This brine is saturated with dissolved methane and toxic hydrogen sulfide. It contains almost zero oxygen. For most deep-sea life, to enter the brine is to enter a vacuum, a poison trap. The cells of any fish or crab that drifts in are instantly destroyed by the extreme salinity in a process called osmotic shock. They die in seconds. So, where does such a deadly anomaly come from? To answer that, you have to look down, deep into the planet's history. Millions of years ago, entire oceans dried up. The ancient Tethys Sea, the ancestor of the Mediterranean. unvanished in an event scientists call the Messinian salinity crisis. It left behind colossal layers of salt, some more than 2 miles thick, which were then buried under new layers of sediment. Now think about what that means. For eons, this salt has been sitting there under immense pressure. When seawater finds a crack in the seafloor, it seeps down, dissolves this ancient salt, and becomes unbelievably dense. This heavy brine, now loaded with gases from the sediment, is eventually forced back up to the surface. It erupts from the seafloor and pools in depressions. It forms a lake. In 2014, marine biologist Eric Cordes was exploring the Gulf of Mexico when his remotely operated vehicle stumbled upon a new one. The team nicknamed it the Jacuzzi of Despair. It was 100 feet across and 40 feet deep. On the water inside was a warm 66 degrees Fahrenheit, a stark contrast to the 39-degree water surrounding it. It was a warm bath of death. And here's the part that scientists are only now beginning to grasp. You'd assume nothing could possibly live in such a place. You would be wrong. Look closer at the edge of the brine. The mussel shells aren't just a graveyard. They are a foundation. Living on that toxic shoreline is a unique ecosystem of specialized tube worms and bacteria. These are extremophiles, life forms that defy all our expectations. They don't need sunlight, they don't need oxygen, they breathe sulfur, they feed on methane. They perform a process called chemosynthesis, creating energy from chemical reactions in the total darkness. They are a blueprint for how life might exist on other worlds. I'd like the sunless oceans of Jupiter's moon Europa. This deadly lake, a place of certain death for 99% of ocean life, is a thriving metropolis for this select few. It's a paradox, a poison that gives life. These pools have been stable for thousands of years, quietly sitting on the ocean floor, harboring life from another world. But they sit atop immense geological pressure cookers. They are the visible signs of huge, volatile deposits of salt and trapped gas beneath the seafloor. And that leads to a terrifying question. What happens if the geology that contains them shifts? So, you've seen the bizarre life that clings to the edges of these deadly pools. The tube worms, the blind crabs, the microbial mats that shimmer like oil on water. It's easy to get lost in this strange alien biology, but you're looking at the wrong thing. The real story isn't about the life that survives here. It's about what lies just beneath the seafloor, waiting. Here's the part nobody talks about. These brine pools, especially the ones in the Gulf of Mexico, are not just salty anomalies. They are geological markers. They are signposts pointing to something far more volatile sealed under immense pressure. Think of them as the cork in a bottle filled with methane. You're looking at a substance called methane hydrate. To you, it looks like white ice. But it's not ice. It's a cage of frozen water molecules with a methane gas molecule trapped inside. A gas cage. It only stays solid under two conditions: extreme cold and crushing pressure. Exactly the conditions you find 1,000 meters below the waves. And the amount stored down here is difficult to comprehend. The U.S. Geological Survey estimates that the total amount of carbon locked away in gas hydrates is double the amount of carbon found in all the world's known coal, oil, and natural gas reserves combined. Read that sentence again. Double. Everything we've ever burned. And there's twice as much of it trapped in this fragile, icy form. These brine pools are often found directly above massive deposits of it. They are the surface expressions of a deep, unstable geology, a geology that is changing. Because our oceans are warming. Not just at the surface. The heat is penetrating deep into the abyss. And a change of just a few degrees can be enough to do one thing: to melt the cage. For decades, the fear was a leak, a steady release of methane into the atmosphere, accelerating climate change in a terrifying feedback loop. A powerful greenhouse gas, 80 times more potent than carbon dioxide, bubbling up from the depths. That was the accepted story. But what if it's not a leak? What if it's a blowout? Imagine a section of the seafloor the size of a city suddenly failing. The methane hydrate, no longer stable, converts from a solid directly to a gas. It expands instantly to 160 times its original volume. The result is a submarine landslide, a colossal avalanche of mud, sand, and gas hurtling down the continental slope. This isn't a theory. It has happened before. 8,200 years ago, off the coast of Norway, a section of seafloor the size of Iceland collapsed. This was the Storegga Slide. It displaced 3,000 cubic kilometers of sediment. The collapse triggered a tsunami that sent a wall of water 20 meters high, crashing into the Shetland Islands. It washed over the coasts of Scotland and reached as far as Greenland. It was a regional extinction event. And scientists now believe this prehistoric catastrophe was triggered by destabilizing methane hydrates. Now, look back at the Gulf of Mexico. Look at the thousands of square kilometers of seafloor where these conditions exist, where the brine pools act as vents for the pressure below. Think about what that means for a city like New Orleans, or Houston, or the entire Caribbean. We send billion-dollar submersibles to study the crabs that die at the edge of a poison lake, while the lake itself is sitting on the trigger of a gun pointed directly at our coastlines. The dark irony is right in front of us. We are obsessed with the morbid beauty of this deadly oasis, a place where nothing from our world can survive. But the real terror isn't that you can't enter the lake. It's what happens when the lake, and everything beneath it, decides to come out. Imagine this. You are sealed inside the submersible Alvin, a titanium sphere just over 2 meters wide. Outside is 3,300 meters of crushing black water. For hours, you have seen nothing but the ballast of marine snow in the sub's lights. The hum of the electronics is your only companion. The cold of the deep ocean is a physical presence, seeping through the hull. Your world is a tiny porthole 10 centimeters across. The pilot's voice crackles over the comms. Approaching the target. You press your face to the thick acrylic, and you see it. It makes no sense. Below you is a lake. Its surface ripples, a mirror of shimmering water distinct from the ocean around it. The sonar shows a clear bottom 12 meters below the lake's surface. A lake within the ocean. Dr. Eric Cordes saw this for the first time in 2014. He and his team were exploring the Gulf of Mexico. They were looking for deep-sea corals. They found something else entirely. As Alvin descended towards the edge of this impossible feature, the instruments began to scream warnings. The temperature probe plummeted from a chilly 4 degrees Celsius to a hostile 19 degrees. The salinity meter went off the charts. This water was 4 times saltier than the ocean around it. It was so dense, the multi-ton submersible couldn't sink into it. It floated on its surface, like a boat on a lake. And here's the part that changes you. You guide the pilot to the edge. The shoreline. It isn't made of sand or rock. It's made of death. A thick white mat of mussel shells piled high. Preserved crabs, legs outstretched as if they simply walked in and stopped breathing. Fish are frozen in their final moment. The brine is completely anoxic, zero oxygen. It's also saturated with toxic methane and hydrogen sulfide. For any complex creature that enters, death is instant. It's a perfect preservative, a tomb. The scientists in that tiny sphere felt it, the profound wrongness of the place. They were floating on a poison sea, surrounded by a graveyard. One of them, Scott Wankel, called it the Jacuzzi of Despair. It's a name that sticks. Think about what that means. You are a visitor to another planet that happens to be on our own. A world with different physics, different chemistry. A place where the rules of life are suspended. The scientists work for hours, their robotic arms carefully collecting samples of the strange mud and the ghostly white bacteria that thrive in the poison. Every movement is deliberate. Or they all know that one mistake, one tiny crack in the viewport from a collision, and the pressure would turn them to vapor in a microsecond. They are more fragile here than any creature on Earth. Finally, the mission ends. The ballast is dropped. Alvin begins its 2-hour ascent back to the world of air and sun, back to life. But the image of that shoreline, it doesn't leave you. It's burned into your memory. You've seen what happens when the conditions for life are removed. You've floated on a sea of death, and you are left with a question that echoes in the silent ascent through the darkness. Are you looking at a relic from the planet's ancient past, or are you looking at a preview of its future? You're looking at a graveyard, a place of death on the ocean floor. But what if it's also a cradle? For decades, our search for life beyond Earth was a search for a mirror, another blue planet, one with clouds, continents, and a gentle sun. We spent billions of dollars pointing our telescopes at distant stars, hoping to see a familiar reflection. But these toxic lakes on our own planet are forcing us to look somewhere else entirely. Not outwards, but inwards, to the dark, hidden oceans within our own solar system. And here's where the perspective shifts. Think of Jupiter's moon, Europa. It's wrapped in a shell of ice, perhaps 15 to 25 kilometers thick. Beneath that ice lies a liquid water ocean, an ocean larger than all of Earth's oceans combined, an ocean that hasn't seen a single ray of sunlight in 4 billion years. Or Saturn's moon, Enceladus, a tiny world only 500 kilometers across. Yet it shoots geysers of salty water hundreds of kilometers into space from its own hidden sea. NASA's Cassini probe flew through these plumes. It tasted them. It found salt, silica, and molecular hydrogen, the raw ingredients for life. So while we were busy looking for little green men, the most profound clues might have been here all along, in these deadly isolated pools. They're not just geological oddities, they are test labs, a proof of concept. The extremophiles thriving on the edges of these brine pools prove a fundamental point. Life doesn't need sunlight. It doesn't need a gentle climate. It just needs a chemical imbalance, a source of energy. Any source. Every probe we send to Europa, every mission planned to drill through that ice, is guided by what we learn in these dark corners of our own world. These lakes are our Rosetta Stone for alien oceans. It forces you to wonder, if life can find a way in the most poisonous places on Earth, what forms might it have taken in the silent, sunless oceans of a distant moon? We have spent our entire history looking up at the stars, searching for a sign that we are not alone. But perhaps the most profound discovery won't be a signal from a distant galaxy. Perhaps it will be a single, simple cell, found swimming in an ocean just like this one, an ocean that has been waiting for us right next door. And when we finally meet it, will we see a reflection of our own distant past? or the face of something entirely new.